Let's talk about infinite geometric series. An infinite geometric series is one that continues on forever. There are two types we look at, converging and diverging. A converging series is one where your common ratio is between -1 and 1. So usually it looks like a fraction, like 1/2, or it might be a decimal like 0.4. But it's no bigger than 1, whether it's positive or negative, is basically what that means. And then you can find the sum if it's converging. If it's diverging, your R value is greater than 1. So we normally look at that as like your absolute value of R. So even if it was a -2, it still would not work because it's diverging, because the absolute value of that would be 2, and that is greater than 1. So it's like whether it's positive or negative, is it a bigger number than 1? And in that case, it would have no sum. So we don't find the sum of a diverging infinite geometric series. I know that's a lot to say, but we'll get to that in just a minute. So the formula to find the sum of the terms of an infinite series is a little smaller than the one we used for a finite series. You just have the first term over 1 minus the R value. So let's take a look at some examples of what they might ask. All right, so first they might just ask, is it diverging or converging, and can you find the sum? So for example 1, you have 3 plus 3/2 plus 3/4 plus, and then you see the little ellipses, like that means it goes on forever. So this one is infinite. It doesn't have an end. And we can figure out between the two terms you start with, you can take in your calculator or in your head and divide. 3/2 divided by 3 helps you to quickly come up with what's happening in between each term. And then you just might want to check that the same thing would happen if you divide the third one by the second one, or you could figure out this number and then multiply. So what I figured out was it's multiplying by 0.5 or 1/2, either way you want to think about it. But like I say, a quick way to figure it out is take the second term divided by the first term. So it's 0.5 each time, or 1/2. And so if R is equal to 1/2, that is less than 1. And we would say that this one is converging, and we could find the sum. So it has a sum. All right, on to number 2. So you have 4 plus 2 plus 1, etc. So 4 down to 2 was multiplying by 1/2 again. It's getting smaller by 1/2. So the same thing would happen here. It's converging, and it also has a sum. But it looks a lot simpler than that one did. Notice how they're the same. And then for number 3, what I figured out was 15.3 divided by 17. Like I say, is a quick way to figure out what's happening for your common ratio. And I got 0.9. And then you just want to make sure it would work between each term. So like 17 times 0.9 did give me 15.3, and so on. And so if it's 0.9, it's still less than 1. So this one still converges and has a sum. So we would be able to put this one in our formula. But we're just asking this one question right now. Number 4, 6 plus 11.4 plus 21.66. So between each term, I figured out that R would be 1.9. So each time you're multiplying by 1.9. So that's larger than 1. So this one has no sum, and it's diverging. Get my spelling straight. It's diverging, therefore it would have no sum. So you can't put this one into our formula we had on the first board. And then number 5 goes from -20, -8, -3.2. This one is multiplying by 0.4. So it is converging, and it has a sum. And then the last one was 1.4 between each term. So if you multiply by 1.4, then R would equal 1.4, and that's larger than 1. So this one would be diverging, and it has no sum. Let's look at some examples using our formula now. So just like with the finite geometric series, these can look a little different and still mean the same thing. So we still see the big sigma symbol, and what it just means is this one is from 1 to infinity. We're most interested in what is the first term and what is the common ratio. So our sum would be equal to our first term, which is 5, over 1 minus the common ratio. And we just want to make sure that that number is less than 1 once we take the absolute value of it, and it is. It's 2/3 is 0.6 repeating. So you calculate this in your calculator. I would make sure that the denominator is grouped together, and then I got this sum was equal to 15. So you can check and practice and see if you get the same thing I did. On number 2, this only means it's an infinite series. We're most interested in the numbers over here. So the sum is equal to the first term divided by, but this number is larger than 1. If you take the absolute value of 5/3, it's greater than 1. So this one would have no sum. You don't need to go any further than that. For number 3, we're just given the series as a list. So we still have enough information. Here is a sub 1, and then we can figure out what the r value is between each term. So it looks to me like r would equal -3 times -2, 6 times -2, so it looks like r is -2. But then the absolute value of -2 would be greater than 1. So this one diverges, and there is no sum. So we should add that this one was diverging, because 5/3 is greater than 1. The absolute value of that is particularly what we're talking about. That is greater than 1. So 27, 9, and 3, these are multiplying by 1/3. So this one we could find the sum because the absolute value of 1/3 is definitely less than 1. So we would plug in the first term is 27 over 1 minus the common ratio of 1/3. And make sure you type that in all together in the denominator. Be careful. I got 40.5. So you can check and see if you get the same thing that I did for the sum of the ones that work. But remember, with infinite geometric series, not all of them work. So you need